Hi, my name is Trevor Stone, and I'm going to be going over number 27 and 28 from the chemistry final. So number 27 says, rank the following atoms from least electronegative to most electronegative. And here are our options. So to find electronegativity, you look at the periodic table, and as you increase upwards horizontally right, you increase in electronegativity. You can do this by following the arrow that I drew. But there's an exception to this. This bar over here on the right side of the periodic table is noble gases, and all noble gases have very low electronegativities. So since we know our information to solve this problem, let's look at where all the atoms are on the periodic table. Be is located here, oxygen is located next to fluorine, but on the left, and He is located in the noble gas section. And since we know noble gases have very low electronegativities, He would go first, just like in solution A. And then Be is the farthest away from the right-hand top corner, so it would go second, just like in solution A. And then O is right behind fluorine, and fluorine is at the top right, so it would go in this order. So our solution to this is A. So let's take a look at number 28. Number 28 says, when you draw the Lewis dot structure for CO2, how many bonds are there? Here are our options. There are two ways to solve it, and I personally prefer one way, but I'm not going to say what that is because that is up to you. Okay, so you can always just draw the Lewis dot structure, but you have to have background information and know that C always has 4 bonds. So if you know that C always has 4 bonds, then you draw 4 bonds like that, and that's all you can do because oxygen is full and carbon is full. So your answer would be B for that way. And the other way that I was going to show you is this way. E stands for electron, by the way. So you would take the total E's for an octet, which is usually 8, and subtract it by how many E's are present. So then divide it by 2 at the end. So if we're going to take this into our problem, we'd have to go take a look right down here. So 1 is the number of carbons we have, and then 8 is the number full octet. And then we would add it by 2, which is the number of oxygen, times 8, which is the full octet. We would subtract that by the number of carbons times 4, which is the actual number of E's present. And then you would add in that part 2 times 6, which is the number of oxygens present, plus the number of valence electrons actually present. And then in the end, you would divide that all by 2. So simplified, it would come out looking like this. 24 minus 16 divided by 2. If you were to solve this, it would come out 8 over 2. Then you divide that again, and it would come out to be 4 bonds, which is B. So you can do both ways, but I prefer one, and that's up to you.